In our last video, we had an example on iterators with vectors. Now let's start this video with a HashMap example. First, I'm going to import my HashMap here. I will say use std collections, and under the collections I'm going to use HashMap. Now in my main, I'm going to create a new HashMap. Let's say my map equals HashMap new. Now I have a new HashMap. It's going to give us an error here because it says type annotation needed for HashMap, because it doesn't know which type that we are going to use this HashMap with, but it's going to be solved in a second. I will say my map.insert, and inside this insert as the key I'm going to say ls. Let's make this a string, and as the value, let's say 10. I'm going to do this again here. Let's see what the problem is. This should be mutable. And here instead of Alice we are going to say Bob, and instead of 10 we are going to say 20. Now we have our mutable hash map, and we have two values with two keys. So Alice has 10 and Bob has 20. So here I'm going to create my for loop, and inside this for loop I'm going to say key and value my map dot, let's say iter. So here I'm going to print out the values. Let's say has this much. That I'm going to say key and then the value. We forgot to say in here. Again, let's say cargo build. Now let's say cargo run. It says Bob has 20 and Alice has 10. And this is another way to use iterators with hash maps instead of just pointing out the value, because in the vectors we were saying for item in the name of the vector, that here we have a key value pair. We used this before in our course, but just to remind you again, we are using this key value pair here, and we are saying this is in our map. So for the first iteration we are going to have Alice and 10 for the key and the value. For the second iteration we have Bob and 20 for the key and the value. And that's how we can use iterators with HashMap. Even though so far we learned a couple of things which are really good about the iterators, that's the first time I'm going to show you really cool thing about the iterators. Now let's create a vector. Let's say numbers this time. And here we are going to have our favorite vector. Next I'm going to create a vector here called doubled. And this vector will have I32. To create this vector, I'm going to say numbers dot iter dot map. So what does this map do? We know that once we say numbers dot iter, we are actually getting the iterator version of our vector. So we know that it's iterator now after the numbers dot iter function. With the map method, we are saying that for every value, for every variable in this iterator, apply the following function that is given to this map function as the parameter. So here I'm going to put a closure. So closure is just basically a function. They are like the arrow functions in JavaScript. They are functions written in a different format. We are going to talk about closures on the following lessons. Just to give a quick example here, I'm going to say x and x times 2 here. So let's see what's happening. This x is our parameter. Now inside our function body we are multiplying x by 2. It's not that important to understand how this works exactly at this time, because we are going to talk more about the closures as an advanced class. But just to give a quick overview again, this is a function we are having here. Instead of putting this x and x times 2, I could have another function. Let's say multiply, and this multiply takes an x, which is an I32, and returns an I32. What it does is it just says x times 2. Now this is the same thing with this one, but this is just a very long way to write it. We can provide this function here as a parameter too, but that's why we have closures actually. Instead of writing functions where we are going to use this once, we are actually having this closure so that it can make the functionality happen. And since we are not going to use this in many places, we don't have to create a separate function and provide it to here, because we are not going to provide this function to any place else. So after this, what I'm going to say here is dot collect. So now let's see how our errors are gone. First, I said that I will have a vector of I32s with this doubled. Then I created my iterator by saying numbers.iter. Then I said .map. With this map function, I'm saying that I will write a function here and apply this function for each value, for each variable or item that I have in my collection. And I have 1, 2, 3, 4, and 5 in my collection, but here as the closure, I have x times 2. So what I'm expecting to have for every variable is that instead of 1, I will have 2. Instead of 2, I will have 4. Instead of 3, I will have 6, and it will go like this. And with this, I'm actually creating another iterator. So if I have another function here, I can also connect this function with my current iterator, which is 2 times this vector. But instead, I'm saying collect, which means that collect the result. And by collecting the result, I'm creating my vector of I32. So let's have a quick review again. Create the iterator, transform the content, and collect the end result. That way, just with one line, I can create another vector which has values 2 times the first values. Now let's print and see this. I will say println here, and let's see doubled. Now let's say cargo run and see if it works. As you can see, we have 2, 4, 6, 8, and 10. Now I'm going to clear here. Now let's see our second cool function. For that, I'm going to say let even numbers here, and you can guess at this point what we are going to do. And again, I'm going to say numbers, then into iter here. Now I'm going to consume my vector, and then I will say filter. Inside this filter, what we are going to do is exactly what the name suggests. We are going to filter our vector. We are only going to choose the variables that satisfies the condition that we are going to write inside this filter as a parameter. And our parameter will be a closure, and this x corresponds to every value that we got with this iterator here. And what we want to do is we want to check after we divide x with 2, if we get 0, then this means that we have an even number. Then I'm going to collect this. And also we need to specify this type of vector here. Now let's see what we did here. First we created our iterator, then we said that okay, we are going to filter this iterator. We want some of the values but not all. So the values that satisfy the condition that we wrote here, we are going to collect them. So let's see what's our end result here. When I say end result, it sounds like the end game. And I'm going to say even numbers. Let's try this one out. As you can see, we have 2 and 4, which are the only even numbers in our vector. So with the map, we are running a function for each of the values that we have. For the filter, we are actually filtering our vector according to the function we are providing here inside the filter as a parameter. With our first cool method, we updated the values in our vector. With our second cool method, we got the even numbers from our vector. With our third cool method, we are going to find the sum of this vector. Let's put this here. Here I'm going to say sum, and the type will be I32. And again, we are going to say numbers.iter.fold here. So our method is fold, and we are going to say 0 as the beginning parameter here. So what this method does is it actually accumulates the values we have. So by saying 0 here, we are actually saying that start with a 0. If we say some other value, then it's going to start with that value, and we are going to accumulate on top of it. So here inside our closure, this time we are going to have 2 different values, one to accumulate and the other one is the value that we are adding, which is coming from our vector. And what's going to happen with these two values is that we are going to say ACC plus X so that we can have the summation. Now let's print this out and see if it works. And then let's say sum. Oops, obviously we shouldn't say that. Cargo run. We got 15. Let's check this out. 3, 6, 10, 15. It checks out. So as you can see, with one line we can get the summation of the values in our vector, or we can filter out our vector, or we can transform our vector and collect the values. So these iterators are really powerful, and also what we can do is we can combine them. So first I can change my vector like our first example. Then with that result, instead of collecting, I can filter out the values that I want. And after I filter out those values, instead of collecting again, I can chain this with another iterator method, which is fold. So first I update it, then I filtered out, and finally I got the accumulation, the sum of the values that I had in my last iteration. So by just combining iteration and knowing how to use them, we can have really efficient memory safety code, and it's actually easy to read once we are comfortable with using iterators. Since we talk about it, now let's chain and see how it works. I will get rid of this. For this example, let's say chain, and the type will be vector of I32s here. And as usual, we are going to say numbers that, let's say, into iter. And here I'm going to filter out the even numbers like we did before. Now I got my numbers filtered out here, and if your line gets long like this, you can always press enter, which is better if these are on the same line. Let's say map here, and inside this we are going to do the same thing with our first example. And finally we are going to collect the result. So let's see what we are doing here. As you can see, we have a couple of steps here, but after we understand each step, it's going to seem much easier. First, we have our into iter function. With this, we are actually converting this to an iteration. Then we are filtering out the even numbers, and instead of collecting, we are actually using map here. So after this, what we will have is 2 and 4 as we saw on our example. And we are going to have 2 and 4 to 4 and 8. We are multiplying by 2, and we are doing this for every variable in the iteration. For this, our iteration is not the numbers though, it's after what we have this filter method. With this filter method, since we filtered out the 2 and 4, this map only applies for this 2 and 4 which is filtered. And finally, we are collecting our result and putting this into a vector which is I32. Let's say println, and let's write our chain vector here. Let's say cargo run. Now as you can see, we got 4 and 8, what we expected. So by going like this, we can actually chain many more different methods and iterators. Now let me show you something fancy. I'm trying to avoid the word cool since I used it a lot in this lesson. Here we will say use std collections HashMap again, and I'm going to delete this part and going to use this as an iter, and instead of chain, let's say squared numbers. We have the same vector and we will have square numbers as a hash map, so this should be a hash map, and we are not going to even specify what's in it. Let's say squared numbers here too. And since we want to convert our vector here to a hash map, we are going to specify this by going like this. Now as you can see, we have no errors. By just using this notation, Rust can interpret what we want and it can convert our vector to a hash map. Here we are saying we have n and n times 2, so this will be the key and this will be the value. and Rust is clever enough so it creates this hash map out of from this vector for us. Let's see if I was right. And as you can see, our result is a hash map with the keys that are values from our vector and values that we multiplied here. So this way we can even create hash maps just out of our vectors. So that's it, folks. I hope you learned a lot, and I hope you like iterators a bit, because iterators are a very fundamental part of the Rust. I didn't use iterators a lot in the beginning. I use many programming languages, but not Rust specifically, and Rust actually makes use of these iterators in a very, very good way. Since Rust is also a functional programming language, it doesn't depend on the iterators, but iterators makes our code much easier and much faster to write. So again, I hope you liked this lesson, and I will see you on the next one.